When you have a radical equation that has three terms, or at least two of them are radicals, squaring both sides is probably the way to go. So we're going to square both sides of this equation. On the left side, we're using the formula here. A minus b squared is a squared minus 2ab plus b squared. So squaring that out, we have the square root of y plus 5 squared minus 2 times the square root of y plus 5 times 2 radical y plus 2 radical y squared equals 1 squared, which is 1. Now to simplify this further, we have y plus 5 minus 2 times 2 is 4 radical y plus 5 times y, putting both radicals under the same radical here, plus 2 squared is 4, radical y squared is y. So all of this equals 1. So we have, combining like terms here, y plus 4y adds up to 5y. So we have 5y plus 5 minus 4 radical y squared plus 5y is equal to 1. And if I subtract 5y and 5 from both sides, we get negative 4 times the square root of y squared plus 5y is equal to 1 minus 5, which is negative 4, negative 5y. And now, it's a little easier if I multiply both sides times minus 1 first. Because then everything's positive. And we have 4 radical y squared plus 5y is equal to 4 plus 5y. And finally, to get rid of the final radical, we have to square both sides yet again. The result of this, we need some space to write it down up here. Okay, so we have 4 squared is 16. The radical square just leaves what's under the radical. On the other side, we have 4 squared is 16. 4 times 5y is 20y, and if you double 20y, you have 40y. And then 5y times 5y, 25y squared. Now we distribute the 16 on the left, and this becomes 16y squared plus 80y. No changes on the other side. Okay, now we subtract 16y squared from both sides, and also 80y's from both sides. And the result is that on the left we get 0, and on the right we have 16 minus 40y plus 9y squared. And we have just to factor that, and we'll be able to find solutions to this equation. Now we're looking for two numbers here whose product is 16 and 9. 16 is 2 to the 4th power, and 9 is 3 squared. So we have to figure out how to divide up the factors so that the sum of the result is 40. The sum is the middle term. And the fact that 3 doesn't divide into, 3 isn't a factor of 40, means that the 3's can't be split up. Because if a 3 goes into each factor here, each term would be divisible by 3, then their sum would also be divisible by 3, which it isn't. So the 3's have to stay together. So let's say they go down into this term, 9. Then we figure out, how do we distribute the 2's? Well, let's put a couple of them here and a couple of them there and see what happens. This then is 4, and this is 4 times 9 is 36. So that adds up to the correct thing. This means that if we rewrite the middle term, negative 40y, using 4 and 36, we can use then factor by grouping to finish solving the problem. So let's do that. So we write this as 16 negative 4y negative 36y plus 9y squared. And negative 4y negative 36y adds up to negative 40y's. And now we can use factor by grouping to factor this polynomial. So first of all, we can factor out a 4 times 4 minus y, ends up getting 4 times 4 is 16, and 4 times negative y is negative 4y. And then we know that this also has to be a 4 minus y factor over here. So it had to be factored out as negative 9. Negative 9y. Because negative 9y times 4 is negative 36y, and negative 9y times negative 9 is positive 9y squared. So that means our factorization is 4 minus 9y times 4 minus y. So this is 0 if one of those factors is 0. So we get two possible solutions. This factor is 0 when y is equal to 4/9. Or this factor is 0 when y is equal to 4. So there's two possible solutions to this problem. And we have to check them both out to see if one or both